Hello, sorry for all the delays. Let's just get into this. This is supposed to be a follow-up on my last big video. This video is supposed to go into how to actually control the gun placement to get it to do what you want. Because that's the part that I think a lot of people are struggling with. A lot of people don't really fully understand how to incorporate into their builds. This is like one of the things that you have to understand for a higher level of building these types of systems, like radars, recoil tech auto turrets, so on and so forth. I'm using MS Paint for this, which means it'll be very fun trying to edit this, so sorry in advance for that. Now, to show, first I want to draw a model to display how I'll be showing the different guns. So, the center of the circle is where the gun's positioned. The line inside the circle is showing where the center of mass is. And the lines on the outside of the circle show in what direction the force is going. And the first thing you'll notice is that all the lines on the outside are facing in a single direction. This is because, let's say as an example, there's something directly ahead of the turret. There's no force in either direction, so the line is straight. Oh, the turret is turning very hard to one side. It'll apply an equal amount in the other direction, keeping the line in the same direction in this diagram. That's why I chose to draw it like this. It's very simple and easy to understand. So, how do I increase the force? Well, just stack more. The lines increase, the forces just stack together and average out, so it'll work just fine. How do I increase the FOV, just the field of view, just in the front? Let's just say that for now you're just trying to increase it in the front. See, the actual direction in which the gun is pointing doesn't actually matter. It's its position relative to the center of mass that matters. So if you have two guns behind the center of mass, the first one pointing 10 degrees to the right, second one pointing 10 degrees to the left, it'll just add those forces together so that on the far, very, very far right, there's a little bit of force, like 40 degrees of just the power of one gun. Then the second gun is also applying force there because, you know, they're separated a little bit so that they don't perfectly overlap. And same thing on the other side. What happens is in the middle, the forces actually cancel out. So there is a dead spot in the middle where it doesn't make any corrections. This is not good for precision. However, it is useful because it's very controllable and effective, right? And if you wanted to make sure that it still tries to maneuver, even if the enemy is already within that middle gap where the forces average out, you can just add in another gun, this time facing just forward, which would, you know, add in even more force facing forward. As you add more and more and more in this hypothetical example, you'll see how it turns into a gradient, where the more you add, the smoother it gets, where it's a lot of force right next to the middle, and less force as you go outwards and around the circle, as less and less guns overlap at the very, very edges. But the thing is, this only applies to the forward direction. It starts getting a lot more complicated when you start considering backwards direction and sideways direction. Backwards direction, it's pretty much the same thing. You can add the guns together, stacked, slightly spread apart, or just on top of each other to add the forces together or to add increased FOV. Same basic concept applies. It starts getting weird once you get past 45 degrees. So let's imagine that you have the center of mass in front of the guns, and the guns, there's one facing straight right like just 90 degrees directly right, and one facing directly left. Now we start getting into other problems. Not necessarily problems, but other designs and like issues. Because now that they're facing straight right or straight left, if they see a target, they'll turn slightly up or slightly down. The recoil of the other one is more perpendicular to the center of mass. It is going to apply more, it's not going to apply more force, it's going to apply the force more efficiently to rotate it. So instead of rotating how you would think it would work, when viewing sideways, it is less responsive and rotates in reverse. It's kind of hard to explain without examples. And it's a lot better when there's like physics demonstrations of it, which I should hopefully be putting up a clip of it right now. Imagine that those thrusters is the recoil of guns. Imagine that that one is seeing something and therefore turning. You could see how the net force makes it spin. And that's pretty much the biggest thing that's pretty much it. That's the whole thing. That's it, yeah. I I basically figured this out through a little bit of trial and error and just figuring it out in my head. There's probably a math way to do this. There's probably a way that's more efficient. I'm still not quite sure how to get those 45 degrees, like the stuff that's in the corners, because I just described how to do forwards, back, and side to side. I still don't really have a very nice, effective detection system for like the corners, like the top right, bottom left, bottom right, and so on and so forth. But yeah, that's it. Yeah, good luck, gamers, I guess. I'm helping a friend do armor stuff in Trailmakers right now, so you're probably gonna see some of that, or not see some of that. I don't know. Goodbye.